For this example, we want to graph the quadratic negative quantity x minus 1 squared plus 4. So what we want to do here to start is translate the information that we have with that equation, with that function, into the pieces that we need from that general form, where we are given that, for one, a is equal to negative 1. That's that first coefficient there. That's what tells us whether we're opening up or down. Be careful. That negative sign is hiding a 1 with it, so keep that in mind. And then also, because we have x minus 1, that means that h is equal to 1, and then we have plus 4 on the outside, so k is equal to 4, and that tells us that we're looking at something that opens down with its vertex at the point 1, 4. Pretty important to have there in mind for where we're going to end up. Next, we want to talk about things with our intercepts, and whether you start by finding the y-intercepts or the x-intercepts, the book likes finding the x-intercepts first. It likes finding the roots first. Roots are generally very important values to have, so I understand why they do that, but you can find the others first if you prefer, and often it's a little bit easier, but we'll follow with the book's process. So if we want to find the x-intercepts, that means y is equal to 0. So we say f of x equals 0 here, or equivalently 0 is equal to negative on the outside, x minus 1 squared plus 4, or negative 4 equals negative x minus 1 squared, or taking out the negative, taking a square root. Again, a lot of things we're going to see here we've done a few times, so I'm going to be a little bit quicker with details, but hopefully you can follow along what I'm doing. Take out that negative, take out the square root, and we will get plus or minus 2 is equal to x minus 1. And then you take that, and I'm going to try and save some space here because I need to have that graph down here somewhere eventually. But we take that piece, we add 1 to both sides. If you add 1 to negative 2, you would end up with negative 1. So you have negative 1, and then if you add 1 to 2, you get 3. So our x-intercepts are at x equals negative 1 and x equals 3. And then for our y-intercept, for the y it's there, here, let me just make it clear that I'm looking for the x-intercepts there. For the y-intercepts, we look at f of 0, which in that case would end up being, keep trying to put the negative on the inside, bad habit, but that is negative 0 minus 1 squared. That's a whole bunch of negatives we're going to be chasing around in there. It's going to end up being negative 1 plus 4 equals 3. So we have the y-intercept at 0, 3, and that means if we want to be able to graph this, we can talk about the points that we have. We have the vertex at 1, 4, the two intercepts at negative 1, 0, and 3, 0, and then the y-intercept at 0, 3. Draw your parabola through that, and you'd end up with that kind of picture, like so. And this is the sort of process you want to do for any of them, although, again, there are some variations depending on the exact type of parabola, the exact locations for parts of the parabola, where sometimes the y-intercepts are less convenient, sometimes they're a little bit less existent, but you should always get at least one point in that way, and then you can use symmetry to get the other, where in this case, because we have our vertex along x equals 1, that means we have vertical symmetry along that line. And if we want to talk about the domain, we can put any real number in there, but we have that maximum at 4, so our range would actually go from negative infinity to 4, including 4. Anyway, that's one thing we can do here. So next, we'll look at a different form called the general form, which is probably what you're a little bit more familiar with.